10 liters of drinking water can be drawn from the atmosphere each day using solar hydropanels, a water extractor powered by the sun. As independent sources of drinking water, atmospheric water generators, which efficiently extract water from the air by gathering airborne water vapor and condensing it into liquid, have a lot of promise. However, places suffering from drought and those without dependable or safe water supplies are great candidates for water production and purification equipment. They can also be utilized in homes and buildings in industrialized nations. They are ideal for off-grid homes and emergency aid kits. The numbers speak for themselves. 40% of America's 50,000 community water systems have had water quality violations, according to the EPA. Only 15% of Americans still primarily use wells to obtain their water. In 50% of the instances, that water wouldn't pass a quality test. The community water systems that deliver water to over 450,000 Californians do not abide by the Safe Drinking Water Act. According to research, American households with limited access to clean water and poor water quality are more likely to have lower incomes and live in areas with chronically underfunded infrastructure. In California, fewer than 10,000 people are served by 96.4% of failed systems, and fewer than 100,000 people are served by 100% of them. The drinking water tool from the Community Water Center precisely pinpoints which communities experience both economic and environmental disadvantage. These water systems frequently contain pollutants like E. coli, lead, copper, uranium, nitrate, arsenic, and nitrate. How does it work? Each source array consists of 2 hydropanels as well as conventional solar panels. A fan and the system's communication with the hydropanels are both powered by the photovoltaic in the center of the array. The actual hydropanels are constructed from 2 special, proprietary materials, one of which has the ability to generate heat and another of which has the capacity to absorb moisture from the air. They can condense water into a 30-liter tank on board, where calcium and magnesium are injected to mineralize it. Some water generators, such as the water seer, are subject to a great deal of hype and skepticism yet fall short of expectations. Some are a little more expensive and difficult to operate, such as the Blue devices, but they do exist, can be bought, and can be installed. The Zero Mass Water Source device is a rooftop solar device that not only generates power but also water. The source hydropanel arrays from the company are now available in the U.S., where they may be utilized almost all year long and in almost any environment. 2 hydropanels make up a standard source array, with more panels being added as necessary for the local climate or water production. The roof of a building is where this independent device is intended to be put, where it can normally create 4 to 10 liters per day. The device's outlet can easily be connected to a building's tap, refrigerator, or dispenser. The collected water is stored in a 30-liter onboard tank that contains calcium and magnesium. The only maintenance needed is to have a subscription service replace the annual filters as needed and the mineral cartridge every 5 years. The system will produce enough water, without plastic waste, to fill 43,800 water bottles throughout the course of its lifetime. A solution to water scarcity. Zero Mass Water claims that even people living in low humidity and dry places may use source devices to generate water, although many system skeptics raise this concern. Despite the low relative humidity, the array at Zero Mass Water's headquarters in Scottsdale, Arizona, continuously produces water. In the summer, the Phoenix metro region can see relative humidity levels as low as 5%, but source still manages to produce water in these extremely dry conditions. Equipment used to produce source water is expensive, at least initially. A standard array with 2 panels costs around $4,000, plus another $500 for installation. It is designed to last for at least 10 years. When the price is averaged by the lifespan of the device, it equals about $1.23 each day, or between 12 cents and 30 cents per liter.